construction of digital cameras is very similar to that of traditional ones. Their most important components are the body, the objective lens, the diaphragm, the shutter, and a light-sensitive surface or image sensor. The difference is that digital cameras transform the image into electrical signals and store it in this form too. In the case of traditional cameras, light produces a chemical change in the light-sensitive film. Digital cameras can be grouped into several categories. The best known are the digital single-lens reflex cameras with interchangeable lenses. Mirrorless interchangeable lens cameras are also becoming widespread. Compact cameras do not have interchangeable lenses. Bridge cameras within this category have a wide zoom range. They represent a transition between the simplest cameras and the higher quality DSLR kind. Most digital cameras are also able to record videos. To take excellent photos, we often need accessories besides the camera because it is difficult to shoot in low-light conditions, for instance. If there is not enough light, the camera's shutter has to stay open longer, which may lead to camera shake or the movement of the subject, resulting in a blurry picture. The flash serves as an artificial light source, and the tripod prevents camera shake while shooting. When we take photos, light rays are gathered by the objective lens. This is actually a set of lenses in which the position of the lenses can be changed. This enables us to change magnification. That is, we can zoom in on our subject. Image distance, the point where light rays converge, can also be adjusted, making our subject appear in focus. The objective lens comprises several lenses to correct the imperfections caused by lens aberration. The light then travels through the opening in the diaphragm, called the aperture, which regulates the amount of light entering the lens. If there is too much light, the width of this opening is reduced, and if the light is too low, the opening widens. The depth of field can also be adjusted with the aperture. A smaller aperture results in a deeper depth of field. That is, the subject and the background are also sharp. A larger aperture, however, results in a shallower depth of field. That is, only the subject will be sharp. In single-lens reflex cameras, after light passes through the aperture, it reaches a mirror positioned at an angle to reflect it through a pentaprism to the viewfinder. The pentaprism ensures that the image we see in the viewfinder is not upside down. Some cameras have a semi-transparent mirror with a secondary mirror behind it that is perpendicular to it. This secondary mirror directs part of the light towards a focusing screen and then a sensor array to operate the autofocus system. When we take photos, the mirror flips up and the light travels straight through the shutter, which opens at the same time, allowing it to reach the light-sensitive surface. That is, the image sensor. The shutter stays open for a short time if there is strong light and longer in low-light conditions. A short exposure time and large aperture are ideal when shooting moving objects so that the image will not be blurry. A long exposure time is necessary for taking pictures of the stars at night, and the camera has to be placed on a tripod. Passing through the shutter, the light reaches the light-sensitive surface, or image sensor, which comprises millions of photosites or pixels, and is converted into electrical signals which are processed by the camera's processor. These are then stored on the memory card in the same form for each pixel. The ISO sensitivity, the image sensor's sensitivity to light, has a very wide range. However, if we raise the ISO number, the amount of noise in the image also increases. Modern cameras adjust the focus, aperture, shutter speed, and ISO setting automatically. But many other automatic, semi-automatic, and manual modes can also be selected. Cameras can take color photos because tiny red, green, or blue color filters cover each pixel sensor. The camera's electronic thus know the color of the light the different pixels have captured. In cameras without a reflex mirror, light continuously reaches the image sensor, so the image seen by the lens is always visible on the LCD screen at the back of the camera. This also serves as a viewfinder.